Compact training video. I'm now going to show you how to find the RCM value for a yeast strain. This is known as RCM calibration. The RCM value characterises your yeast for the compact yeast monitor. It allows the system to take account of changes in the conductivity value of the yeast. We are going to use a sample of the yeast you want to find the RCM of. We're going to use some salt to change the conductivity of the yeast sample. You need your working compact system, as we've talked about before, and we're going to use a computer with an Excel spreadsheet on it. You can type the values you measure into the spreadsheet and use it to calculate the RCM value, which you enter back into the V350 screen. You do not have to use a computer, you can do the calculation on paper just as easily. To begin with, you're going to take about 300 millilitres of yeast slurry and add it to the sample chamber. You'll notice it pours easily and is not too thick to use in the sample chamber. It's about 25% spun solids. I'm going to turn on the stirrer. There's a magnetic flea at the bottom. We want the yeast to be a consistent sample in the chamber, so we want it to be well stirred but do not want to create a vortex in the chamber. I'm now going to show you the V350 menu screens for calibrating a yeast strain. We have our yeast sample in the Bay event being measured by the compact, and the value is coming up on the main screen. The stirrer is keeping the sample completely homogeneous throughout. On the main menu, I'm going to press Menu, and then I'm going to press Strain Setup. Strain is a term used for the yeast type. You can have from 0 to 19 different strains or yeast types. Today I'm going to calibrate strain number 1. First I'm going to put in a name, which is going to be Aber, and then press Enter. So once you've added the name, you press Set, save the name and move on to the next screen. On this screen, you'll see you have the RCM value part and the percent spun solids factor part. To begin with, the percent spun solids factors need to be set to 1 and the RCM value set to 3. In this case, while you're measuring your yeast sample with the RCM at 3, you can see you get about 26.8% spun solids value. Record that number in your spreadsheet or on your paper. You're then going to increment the RCM value by 0.5. So I put 3.5, then Enter, and then press Set to accept the value. You see the value jumps up to the current position and you'll see the concentration value changes. Record the new percent spun solids concentration value and then change the RCM value again to 4. Set it and see the concentration value changes. Record it and keep going, incrementing the RCM by half each time till the RCM value reaches 9. Eventually the screen will look like this, with 9 on it, and in this case concentrations drop down to 21.16% spun solids. You should have all the values recorded in your spreadsheet. Next, you increase the conductivity of your yeast sample and repeat the procedure. So carefully add some salt until the conductivity reaches 4.5 millisiemens per centimetre. Be careful you do not overshoot and add too much salt. Make sure the salt is stirred into the yeast correctly. Go back to the RCM on the V350 screen. Set it at 3. You'll get a different value for concentration and repeat 3, 3.5, 4, recording the values every time and entering them into the spreadsheet. Let's look at the spreadsheet now and you'll see how you'll get your final RCM value. This is the Excel spreadsheet that will help you with the RCM calibration of your yeast strains. You can see here you have the name at the top, Aber, and you have this table which you need to fill in. You see the RCM value 3, 3.5, 4 up to 9, which we've already talked about, and you can add the values here. I'm going to add some values which I previously prepared for you. You see, as I add the values, the graph on the right starts to draw the red line, which is low conductivity value line. I'm going to skip ahead and show you all the values filled in. As you can see, you get this curved shape. Next, you add salt to the sample and you repeat the process. By doing this, you get a second set of values and you enter those too. Then the graph will look something like this. You've got both columns filled in and you'll have a green and red line. Where the two lines meet is your RCM value, which you're going to use with your yeast strain. And you'll see down here towards the bottom of the spreadsheet that will be 5.5. On the compact instrument, I'm going to set the RCM value to 5.5. So once you've completed your spreadsheet and you've got your RCM value, you need to enter it into your strain calibration. So we have 5.5 set, and then that's the value you're going to use for this yeast strain. Next, you're going to move on to the percent spun solids calibration. I'm now going to show you how to get the percent spun solids factor and cells per mil factors for the yeast strain. Look at the spreadsheet and you can see there are two sets of boxes you need to fill in. This is where the lab readings for your sample come in. So first you're going to enter the lab spun solids reading and then the Aber reading from the V50 screen. I know that my lab reading is 26.3%, so I enter that in the spreadsheet. Next I enter the Aber reading from the V50 screen. You'll see it is reading 16.2, so I put 16.2, press enter, and it gives me the green value, which is the percent factor to enter into the V350. I'm going to put in 1.62 into the V50 screen. I'm going to press set to accept that change. You'll now see the concentration has jumped to 25.95%. It's not quite the 26.3% we want. This is normal because it's not a linear factor. So I'm going to increment the percent spun solids factor just to nudge it up to where I want it to be. I'm going to put it at 1.64. That gives me the 26.3% that matches my lab measurement. Now your compact yeast monitor is measuring the same percent spun solids as your lab readings. Next we're going to move on to do the cells per mil or CPM factor. Press next on the V350 and it gives me another screen, which is the cells per mil factor screen. I'm going to go back to the spreadsheet and in the second part of this calculation I'm going to add the lab cell per mil reading. This is the viable cells per mil, not the total. I know this to be 1.56 billion. I know the Aber reading is 26.3% for percent spun solids, and so it is going to give me a factor of 5.94 times 10 to the 7. I'm going to enter that factor into the V350. So it's 5.94 exponent 7. I press set, it accepts the value, and you can see the concentration of the cells per mil is 1.56 times 10 to the 9, which matches the lab value we were given. So that's your viable cell count. Once we're happy with that, we press back and back again to get onto the main screen. You can see that the concentration value is now reading correctly, matching the laboratory values. So your compact system is now calibrated for the Aber yeast strain and can remain so for a long period of time. I've now shown you percent spun factors and CPM factor calibration, but it's worth noting that depending on your brewery and your particular situation, you might not be working in cells per mil. In which case, you can stop the calibration point at the percent spun solids factors, and the V50 menu system choose to run the instrument in percent spun solids.